So the ideal solution is a solution which has to be useful to a user. As we have seen in our previous video, that the solution is pretty complex. It's very hard to diagnose this problem. So an ideal solution should be in such a way that once the user reports the battery drain problem, a report has to go into a black box and the user should get suggestions in response. He shouldn't be knowing what the black box does. So our e-doctor operates as that black box, which takes user reports regarding battery drains and provide suggestions to the users as to what needs to be performed to solve these problems. So there are several observations that needs to be performed to develop this sort of a thing. So the number one observation is a phase behavior observation. So basically an app performs a lot of operations, and we can divide an app's operations into several intervals. Several intervals in which some operations of the app are performed. So a group of intervals can be considered as a phase. So a set of operations that are performed by the app can be considered as a phase. So these phases are formed in such a way that the intervals in these phases consume similar resources and similar resource usage behavior. So if an app is making use of a recorder at one interval and is making use of camera in other interval, then these two intervals should not be in the same phase, because their resource usage is not the same. One is using a recorder and another is using a camera. Let's say two intervals are making use of recorder, then these two should be in the same phase. So that is how phase behavior observation starts, with forming phases. So in this way we can categorize phases and we can identify phases which are consuming uncommon amount of energy. So to make this study, we have two methods in which we can study the phases and the resource consumption by phases. So the first one is a resource type vector. So it records the type of resource in each execution interval. As you can see in the diagram, the top part consists of phases from phase 1 to phase 4, and the bottom part consists of resources: CPU, wake clock, network. So as you can see in the first column, phase 2 is functioning, and when phase 2 set of interval operations are being executed, CPU is being used but not wake clock and network. And in a similar way, in the second column, when phase 1 is functioning, CPU is not being used, wake clock and network are being used. So each unique resource type vector represents a unique phase. So in such a way we are able to categorize different phase and how they are accessing resources. But this method has a problem. because if in a particular timestamp two phases are using same resource, we will not be able to figure out which phase is using more resource and which phase is using less resource. Same is the case when two apps are performing operations and both apps are making use of the same resource. Let's say two apps are making use of recorder. Then we will not be able to know which app is consuming more of a recorder and which app is consuming less of recorder resource. All we know from this resource type vector observation or method is whether a phase is making use of a resource or not. We do not know how much of the resource is being used. That is a huge disadvantage. So this led to second method, which is resource usage vector. So what this does is it records the resource usage amount in each interval. As you can see, it's no more 1 or 0 when it comes to resources. It shows how much of CPU is being used in each phase, how much of wake log is being used, and how much of network is being used. And as it is evident, there are 5 phases which are consuming more space, and the control is switching between the phases more frequently. So this would help in categorizing phases and their resource usage in a more effective manner. And then the second type of observation that needs to be done other than phase observation is event observation. So usually, as you can see from the diagram, battery performance will be normal. Then some trigger event takes place which makes the battery performance go from normal to abnormal, which is the battery drains fast. So if we can figure out what the trigger event is that is causing this problem, then pretty much our problem is solved. So with these observations, we can move into building eDoctor, because we know what our eDoctor has to do to solve this problem, and we can use this information to build eDoctor. So we'll discuss the architecture of eDoctor in the next video. Thank you.